Earth's is consumed. This is an even bigger supermassive, a hole with the mass of 2.5 billion suns. It's at the center of the galaxy Virgo A. A great plume of material ejects across space. Here's Virgo A from the Hubble Space Telescope, the jet plainly visible. And this from a telescope on Earth. But the most incredible black holes are linked to quasars. Quasars burn at the center of remote galaxies, so fierce and bright that they outshine the galaxies themselves. Quasars are fueled by the hungriest black holes, supermassives that consume the equivalent of 600 Earths an hour. These are Hubble pictures. Quasars are among the most luminous and powerful objects in the universe. Albert Einstein, the great 20th century physicist, predicted many of the effects of supermassive objects. His general theory of relativity explains how bodies not only bend light, but distort the space around them. Our universe ripples with the push and pull of gravity, the exertions of supermassive objects. A black hole is the ultimate distorter. It so bends space and light that we've no idea what happens inside. It could be a wormhole to other parts of the cosmos, even to another universe. A quasar, the core of a distant galaxy, an image in both visible light and radio. Take out the visible, and radio reveals what it brings to the picture, especially the jet. An optical picture of the galaxy Centaurus A. Radio shows it's in turmoil, the aftermath of a galactic collision. A pulsar, a tiny superdense star spinning 30 times a second. With radio, we see its powerful radiation beams. To astronomers, infrared is important. It picks out warm cosmic dust. But, like ultraviolet and the longest radio waves, relatively little penetrates our atmosphere. By and large, only visible light gets through. Most invisible radiation is absorbed by our atmospheric shield. To overcome the problem, detectors operate in Earth orbit. This is ISO, the Infrared Space Observatory. ISO must keep cool or be blinded by its own emissions. Anything hot radiates infrared. Veins of circulating liquid helium absorb heat and vent it from the craft. ISO is the coolest laboratory in the universe, minus 450 degrees Fahrenheit. But infrared pictures are hot. Here in the constellation of Orion, infrared unveils vast clouds of gas and dust, a birthplace of stars. In ordinary light, the Large Magellanic Cloud, a galaxy very close to our own. In infrared, it displays great wafts of dust, where stars are born. The Andromeda Galaxy in ordinary light, and here in changing wavelengths of infrared. By highlighting clouds of starbirth, infrared reveals Andromeda's spiral structure. Within our own galaxy, ISO gathers radiation from clouds between stars. Its long-wave spectrometer specializes in the job, imaging nebulae in the pangs of stellar birth. Still in infrared, but closer to home, ISO tracks a comet, its trail like condensation from a jet plane. In ordinary light, a comet's heart is obscured. But infrared gets through, and to the shells of dust that surround it. ISO, an eye on the invisible. By contrast, the Hubble Space Telescope is famous for the visible. But Hubble has peripheral vision too. Infrared to one side, ultraviolet to the other. It's like stripping the veneer of a cosmic portrait. In ordinary light, a Hubble detail of the Orion Nebula. Pierce the dust with infrared, and Hubble uncovers cocoons of young stars. Again, in ordinary light, this Hubble picture hints at the next stop on the spectrum. The blue halo is from hot young stars radiating ultraviolet. The Andromeda Galaxy in ordinary light. But in ultraviolet, clouds of hot gas where massive stars die young. Time-lapse of the sun, ultraviolet unmasking its churning surface. Shorten the wavelength to X-rays, and there are the hottest, most energetic regions, plus the corona, the searing atmosphere of the sun. The night sky as we see it, and as it is in X-rays. At the pivot of two galactic jets, Hubble identifies a massive black hole. The Andromeda Galaxy, and evidence that it once consumed another. Hubble discovers a double core. In the Whirlpool Galaxy, it spies a suspected black hole. And here, the remnant of a supernova. The Pillars of Creation, one of the most spectacular pictures ever taken of the cosmos. It's part of the Eagle Nebula, where stars are born. A dying star in the Cat's Eye Nebula. In gamma rays, a panorama of our galaxy, the Milky Way. The hot band across the center, cosmic rays colliding with interstellar gas. The Milky Way in X-rays. In infrared, showing lots of dust. In the wavelengths of radio. And in the radiation we know best, visible light, just part of the cosmic orchestra, but nonetheless exquisite.